Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Hanim Akmal bin Rosman. Today I want to present a mini project about circular water tank. My group member is Nur Hidayah binti Amran, Nisrina Nazihah binti Muhammad Riza, and Farah Nabiha binti Muhammad Ghazali. So for this slide, we have table of contents. First, we have introduction. Second, we have analysis of model. Third, we have justification, and the last one is conclusion.
Next, the introduction. What is borehole? The first, a borehole is a narrow shaft bored in the ground, either vertically or horizontally. Next, to drill for extraction of mineral, relying on a process that was high pressure water. And then a borehole was dug to detect the nature of underground soil and to extract water for storage in a water tank. And lastly, a water storage tank is a container that holds clean water for use in a variety of applications, and a site study will be conducted to explore the subsurface in order to construct a circular concrete water tank. At a depth of 1 meter, make a borehole up to the desired depth, and then place that tripod concentrically above it. Take your guide rod and fix the sampler at the bottom, and then attach the hammer and anvil to the guide rod. Fix the center again above the borehole as shown and place the guide rod set up through it. And then attach the hammer to the one end of your rope using hook and make 4 marking along the guide rod. Lastly, drop the hammer through 75 cm height and starting penetrating the soil did you start counting the blows. Next is analysis soil profile. There are 3 types of soil in the depth of 10 meter, which is sand, silt and clay. And there we have 2 borehole, which is BH1 and BH2. From the analysis, we can see that at BH1 we have sand from 0 to 0.3, next from 0.3 to 7.48 we have silt, and from 7.48 to 10 meter we have clay. At BH2 we have sand from 0 to 0.3, and lastly we have clay from 0.3 to 10 meter. So this is our model of circular tank. We have circular tank at above and we put the illustration of soil profile at the bottom. Next is strength correlation with SPTN value. First, at BH1 we have 3 types of soil, which is sand, silt and clay, with depth 0.3 meter, 7.18 meter and 2.52 meter. With gamma unit weight of soil 16 kilonewton per meter cube, 18 kilonewton per meter cube and 21 kilonewton per meter cube. At BH2 we have 2 types of soil, which is sand and clay, with depth 0.3 and 9.7. With gamma 16 kilonewton per meter cube and 21 kilonewton per meter cube.
So this is the graph of depth versus SPTN value. So for borehole 1, at depth of 0.3 meter, the SPTN value is 0. At depth of 1.5 meter, the N value also 0. Including at the depth of 4.5 meter, and then at depth of 7.5 and also 10, the N value is 3. And at borehole 2, at depth of 0.3 meter, the N value is 0, and at depth of 1.5 and 10 meter, the N value is 2. So This is the graph of depth versus vertical stress. At 0.3 meter, the vertical stress is 4.8 kilonewton per meter square, and at 10 meter depth, the vertical stress is 186.96 kilonewton per meter square. For borehole 2, at depth of 0.3 meter, the vertical stress is 4.8 kilonewton per meter square, and at 10 meter depth, the vertical stress is 214.8 kilonewton per meter square.
Lastly is justification. Based on the experiment, the result that we get is can determine the shear strength of soil. The type of soil consists in the study area is sand, silt and clay for borehole 1, while for borehole 2 is sand and clay. Based on the calculation, we can get that the first layer of the soil, which is from depth 0 meter to 0.2 meter, cannot support the load from the water tank. The second layer from 0.3 meter to 7.48 meter also cannot support the load of the water tank, but for the third layer from 7.48 meter to 10 meter, we can conclude that the soil can support the load from the water tank. For the foundation system, we can conclude that the most suitable foundation system is the concrete foundation and always use water retaining coating to foundation.